Chapter 17, Part 6. So we've done vertical axis, and we have done the right axis, our last one. We're going to do a left axis. We'll do this one in a worm's eye view. But I want to take a step back to this diagram. This is the first diagram that we did, where we set up the left station point, a right station point, and a vertical station point. And we got our measuring points here. Left measuring point, and right measuring point, and our vertical measuring point. When we set these measuring points up, we took the distance from vanishing point to station point, and we projected it up to the horizon line. It crossed this reference line right there. This one crosses the reference line right there also. This is our vertical axis point. We found the right axis point just by taking our triangle and setting it like this on this right reference line. You can also use these lines where these cross. This is that right axis point. If you're rotating an object along a left axis, the point you get your true angles from is always going to be along this left reference line. Right here, where these lines come together. You can also use a triangle and find it this way. So these are our 3 points that we use to find angles in 3-point perspective. Here's the drawing we did from a previous video. We have a 1 unit cube in a worm's eye view. It's sitting on the ground right here. Let's take this cube and we'll rotate it clockwise 20 degrees. It's going to be rotating on an axis that goes to this left vanishing point. So we need a left axis point. If we rotate something along a left axis, the lines that go to the left vanishing point will all continue to go to the left vanishing point no matter what degree I turn this. The lines that are changing are the ones that go to the right vanishing point and the ones that go to the vertical vanishing point. Those are the ones that are going to be moving. So we need that spot that gives us true angles between these two. There's 90 degrees between the right vanishing point and the vertical vanishing point. We can take a triangle and put one leg of the triangle on the vertical vanishing point and the other on the right vanishing point, and the 90-degree corner has to be on this left reference line. Right there. I'm going to put this on an overlay because this is pretty busy. So here is our left axis point. Here is our true 90 degrees between the vertical and right vanishing point. So we want this, we're going to hinge it from here. So we want this line to lift up 20 degrees. So we're going to use a protractor for that. This line is also going to come over 20 degrees. When these two vanishing points move, they move along this line. When you're rotating things along a left, vertical, or right axis, the vanishing points will move back and forth along these 3 lines, the lines that connect the vanishing points. The vanishing points are moving along these 3 lines. There can be vanishing points other places than these 3 lines, but that's a different video. Here's 20 clockwise. Here's my mark. This is 20 here. So we move this down to here. I'm going to call this a 20-degree vertical vanishing point. So this is my 20-degree right vanishing point. Here's the 20-degree angle. From here, it's moving up here. And this vertical one is moving over 20 degrees also. And there's our corner. So we'll leave the measuring for the next video.